All right, ladies and gentlemen, so here we are on our third installment of the Decker video series for Earth Science. So what we're going to talk about now is the moon, and we're specifically going to talk about the moon phases. Now, one interesting fact about the moon is that this is the side of the moon that we always see. We never see the other side of the moon. The moon is always half illuminated, and it's always the side that faces the sun. So there is no such thing as the dark side of the moon. Even though Pink Floyd came out with an album called Dark Side of the Moon, it doesn't mean there is one, because half of the moon at any given time is illuminated. Which half? The side that faces the sun. So, as we go through, we're going to learn about the moon phases. Now, this phase is obviously the full moon. So, now if we look at the moon, this is the side that faces us to the left, and the other side of the moon, the far side of the moon, is this one on the right. Now, an interesting fact about the far side of the moon was the first photograph taken of the far side of the moon was actually by a Russian satellite. And that Russian satellite sent pictures back to Earth, and the English actually intercepted the transmission and broadcasted the picture of the moon before the Russians had the chance to do it. So it was during the Cold War, and it was the race to the moon. So everybody was just trying to get up there first, and actually British spies were able to capture the picture and send it back to Earth. And obviously, if that side of the moon didn't receive light, this picture never would have been able to be taken. So again, there's no such thing as a dark side of the moon. All right? The entire surface of the moon, at one point or another, receives sunlight. So the moon's light, where does it come from? It doesn't come from the green cheese. Where does it come from? Well, the moon's light comes from the surface of the moon, and it has to do with how the light is reflected from the sun. So everything we see from the moon is light from the sun that is then reflected off the surface of the moon. And the various colors on the moon's surface are caused by the different types of bedrock. And the soil that's on top of the moon is called regolith. So the bedrock and the regolith that are exposed to the light are what gives the moon the various colors. So if we take a look back at this, and we can see the very dark areas, all right, and the very light areas, and we can see down at the bottom here, this area here, this is actually a meteor, and you can see what's called the ejecta blanket. This is all the material that was broadcast out after the meteor hit. And you can see here this dark area. These dark areas were labeled mares, basically to mean ocean. This was from early Italians, and it actually literally translates for ocean. So like Mare Tranquillus was actually the tranquil ocean. So if we look at this meteor impact crater, we can see that there's a light ejecta blanket. So we have this very dark basaltic lava flows here that created this, and then when the meteor impacted, it hit the lighter rocks inside and then sprayed the ejecta outward. So now, what causes the apparent change of the moon? The moon goes through phases, so the percentage of the surface of the moon that's illuminated, that we see, changes. The diameter of the moon changes as well, and the brightness of the moon changes. So what changes that apparent percentage of illumination? All right, and that is the actual revolution of the moon around the Earth with comparison to its position in relationship to the sun. So as the moon revolves around the Earth and we revolve around the sun, it changes the amount of illuminated moon that faces the Earth. And then what about size and shape changes? Well, it has to do with the shape of the moon's orbit. And the moon's orbit is what's known as an elliptical orbit. An ellipse is a mathematically defined oval, basically. And what happens is at some point, it's closer to Earth, and other points, it's farther away. So when it's closer to Earth, it's actually going to appear larger. And when it's farther away, it's going to appear smaller. So this is why the size of the moon changes. All right, folks, so what we're going to watch here is a clip from the movie Bruce Almighty. And Bruce, actually, in the movie, is played by Jim Carrey, and he's given the powers of God. So let's take a look.
Bruce Almighty, my will be done! What if God was one of us? Just a slob like one of us. Just a stranger on a bus trying to make his way home. Oh my God. You can call me Bruce.
What happened to you? You seem so... happy.
Why shouldn't I be? On a night like this?
Those are amazing. What are these?
They're a new breed. Cross-pollination between tulips and daisies. I call them to daisies.
Okay. Honey, these flowers are really beautiful. But last night
I was only human. Barry, help me out here.
So what changes the size of the moon that we see in the sky? The moon doesn't change sizes. Well, it has to do with the apparent diameter is larger when it's closer to Earth, and it's smaller when it's farther away. So now what we're going to talk about are the names of the moon's phases. So the various names of the moon's phases, if we go through, we have number one is a new moon. This is when there's zero light hitting the sun. First crescent. First quarter, that's when half of the moon that faces the Earth is illuminated. Now, why is that called a quarter? Because we're only seeing a quarter of the moon that's illuminated. First gibbous. That's the one that you think is a full moon, but not quite. And then you have a full moon, last gibbous, last quarter, and last crescent. These are also known as, if we look over here on this side, the first side is known as, okay, so if we look over here on the side where it says first, notice that it's also called waxing. So this is known as a waxing crescent. Now, new moon stays the same. Then it would be waxing crescent, waxing quarter, waxing gibbous. Then it would go to full moon. And then it would go waning gibbous, waning quarter, waning crescent. Okay, and here we actually look at photographs of the moon. New moon, right? The disk is not illuminated. Now, you don't have to worry about a young moon, but that is a young, and it's also known as a crescent. We're going to start with waxing crescent, waxing quarter, waxing gibbous, full moon, waning gibbous, waning quarter, waning crescent, and then you go to old moon, and then it would go back to new moon. Now notice on the waxing, the illuminated portion is on the right-hand side of the moon. The illuminated portion's on the right-hand side of the moon, and as it's losing light, the illuminated portion is on the left-hand side of the moon. So losing light, waning, all right, gaining light, waxing. Now, if we take a look at a picture from space, again, this is Earth as viewed from the North Pole, and the sun's rays are over here with the arrows, and these are the various positions of the moon, and these are all the different phases that you need to know. So if we take a look at this from new moon, which half of the Earth is illuminated? Well, the half of the Earth that's illuminated is the side that faces the sun. So which half of the moon would be illuminated? It's the side facing the sun. So notice in all of these right here, this is the side facing the sun, and that's what's illuminated. That also determines what we see. So why do we see a waxing crescent when it's in this position? Well, if we take a look at these red lines here that I've drawn on here, you divide the moon in half. Remember, we always see half of the moon. It's always the same side. Half of the moon that faces the sun is always illuminated, but that's not always the side facing the Earth. And what we see is this portion here on the right side, which ends up looking like this little sliver, because remember, the moon is a sphere. So now if we switch that to the first quarter, notice that we divide the moon in half, and that's the side that faces the Earth, and then the right-hand side is illuminated, and when we look at it from Earth, we see just this disk, all right, but we see half the disk is illuminated, but it's only 1/4 of the overall moon that we're seeing. So that's why it's called the first quarter. And that goes that way all the way around. Now, also, what we're looking at is basically the same reason that the moon rises and sets at different times. So if you remember, when we look at the Earth as viewed from space, we can tell what time it is going around. So A would be noon, B would be 6 p.m., C would be midnight, D would be 6 a.m. So if we look at here, this would be 9 a.m., this would be 3 p.m., this would be 9 p.m., and this would be 3 a.m. If we draw a line on Earth perpendicular to the moon, that is going to tell us when the moon is going to rise and set. So basically we draw a line perpendicular, right? Go halfway through Earth, perpendicular to the moon. And now this is going to be when the moon rises, and this is going to be when the moon sets. So the moon, our first quarter, will rise at noontime, and it will set at midnight. So it's not in the sky all the time. So let's see what time a waning gibbous would rise and set. So when would a waning gibbous rise and set? So we draw a line through the Earth, perpendicular to a line to the phase that we're after, just like that, okay? This is a right angle, so therefore the rise is going to be over here because of the way the Earth rotates. Remember, the Earth rotates counterclockwise. So we're going to see the moon, and when we come up over the horizon here, and that's going to be at 9 p.m., and it's going to set at 9 a.m. So give it a shot and see if you can figure out what time each of these different phases rise and set. So let's do one more. Let's say the full moon. I'm going to draw that line. I'm going to have that line perpendicular to it. So therefore, the moon rises at 6 p.m. and it sets at 6 a.m. Now here's a question for you. Can we ever see the new moon? The new moon is not illuminated, the side is not illuminated by the sun that faces the earth. But can we see the new moon? Well, what time does the new moon rise and set? So we draw our perpendicular line to the new moon. And the new moon is going to rise here. Why? Because the earth rotates counterclockwise. So it's going to come up over the horizon here. It's going to rise at 6 a.m. and it's going to set at 6 p.m. Now, this diagram is when we are in the equinox. How do we know that? Well, the day-night line goes through the North Pole. Now, think about it during a time when the day-night line's not going through the North Pole. You can only see the moon, the new moon, when there's no sunlight. So when can we see the new moon? Well, the new moon rises at 6 a.m. and sets at 6 p.m. But remember, in the winter time, the sun doesn't rise really early, right? It rises much later. So there's a period, there's about an hour in there till about 7 in the morning that it's dark. And then we have the same thing in the afternoon, right? We have about an hour from 5 to 6 where it's dark. So it'll be very low on the horizon, but we can actually see the new moon. It's called the blood moon. And the reason that we can see it is that the light reflecting off of Earth reflects back and hits the surface of the moon. It's what is known as earthshine. Now, think about it this way. Can you see your shadow when it's a very clear night and it's a full moon out? Can you see? Is it lit up? Yes. Now imagine being on the moon and the diameter is 4 times. The diameter of Earth is 4 times that of the moon. So in the sky, if you're standing on the moon, the object is 4 times the size of our moon, shining back at you. So yes, there's light reflecting off the surface of the Earth that hits the moon and then reflects back to Earth. And as long as it's very dark out, you can actually see the blood moon. So a quick review. What phase would this be? This would be a new moon. What phase would this be? This would be a full moon. What phase would this be? This would be a first quarter or a waxing quarter. This position would be a last quarter or a waning quarter. First crescent, waxing crescent. First gibbous, waxing gibbous. Last gibbous, waning gibbous. And last crescent, waning crescent. What phase? Full moon. What phase? First quarter. How do we know? The illuminated portion is on the right-hand side. What phase? Last gibbous. Illuminated portions on the left-hand side. What phase? First crescent. Now, this is a GIF, an animation file of the moon going from new moon here, going through its phases. Now notice the illuminated portion coming from new moon to full moon, back to new moon. That is what's known as one lunar cycle. That takes 29.5 days. Now this number is not in your reference tables and you need to memorize this. This is how long it takes to go from new moon to new moon, 29.5 days. So to go from new moon to full moon takes half that time. So a lunar cycle, new moon to new moon, 29.5 days. So here's a question for you. Why do we always see the same side of the moon? Because it rotates at the same rate it revolves. What rate does it rotate? What rate does it revolve? This is on page 15 in your Earth Science reference tables. It is 27 1/3 days. So it takes 29 1/2 days for a lunar cycle, 27 1/3 days for the orbit or period of revolution. Why is the period of revolution 27 1/3 days and the lunar month 29 1/2 days? Because the Earth is revolving around the sun at the same time the moon is revolving around the Earth. So therefore, it takes time to catch up. It takes time to catch up. What does that mean? Well, if we look here at this diagram, the moon's phases are caused by the position of the moon relative to the sun and the Earth. So when it's in between the sun and the Earth, that's a new moon. Now, the moon revolves around the Earth. That takes 27 1/3 days. So to go from A back to A takes 27 1/3. Well, by the time it gets back over here, the Earth has now moved over to here. So position A would be here. So now it takes that extra time from 27 1/3 to 29 1/2 to get in alignment again. And that's why you have the different months of the moon. And this is why this is called a sidereal month. That's the amount of time it takes to orbit the sidereal month. And then you have a lunar month, which is the new moon to new moon phase. And if we look at Galileo's book called Sidereal Messenger, it has to do with the movement of the celestial bodies. All right, ladies and gentlemen, so that's the end of the lesson on phases of the moon. Now, if we take a look here, there's a video on the History Channel. It's a very short video you should watch. I'm going to attach the PowerPoint to the Google Classroom so you can access this and you can actually then watch this video.